How are ships built? Building a small boat is relatively straightforward. Form the hull, attach the engine and other electronic components, and it can go on a trailer to be transported anywhere. The entire process could last just a matter of months. But what about something bigger, say a superyacht over 200 meters long? Large vessels are built in pieces and assembled later. These ships take years to build and can cost hundreds of millions of dollars. The modern method is to construct large parts of the hull, for example, the complete bow and stern. Each of these parts is built up from sub-assemblies or component parts, which are then welded together to form the complete bow or stern. These sections of the ship are manufactured undercover in large sheds, generally at some distance from the building berth, before being transported to the berth, and they're fitted into place and welded to the adjacent section. The advantages of this procedure are that work can proceed undercover, unhampered by bad weather, and the units or component parts can be built up in sequences to suit the welding operations, not always possible at the building berth itself. How are ships constructed? Construction starts with bending plates to match the curve of the ship's hull. Since the 1940s, ships have been mostly made of welded steel, and since the 1950s, specialized steels have been used to eliminate brittle fracture. In laser hull, crane moves steel sheet into the place for laser cutting. Once the hull pieces are shaped, framed, and ready, they are assembled. This is a fascinating process where massive pieces of metal are brought together to form a complete ship. The construction is done in segments called sub-assemblies. These assemblies are welded together to form larger and larger pieces, eventually making up prefabricated sections. It's called a block. Block being transported to building hull. Wheels of transport vehicle carrying block to building hull. Operator using remote control to drive transport vehicle with block. Pan of blocks waiting to be moved into place in building. Block being lifted by crane in building hull with 270 visible in background. Overhead shot of crane in building hull. Block being lowered into place in building hull. Steel in shipbuilding. The quality of shipbuilding steels has an extremely large impact on the quality, efficiency, and cost of ships built from those steels. Many steel producers established a system to supply wide and long plates to the shipbuilding industry. A demand for heavy, thick plates with a good combination of high strength, toughness, and weldability has been widely growing in recent years for large shipbuilding. Because of this, ETRA high-strength thermomechanically processed steels (TMCP) have been developed to be more user-friendly than the traditional steels. E-sealant handling properties are based on thermomechanical treatment that reduces the need for excessive use of alloying elements to strengthen the steel. TMCP plates are thermomechanically controlled rolled, and with greater plate thicknesses, also accelerated cooled after rolling. Generally, TMCP steels are supplied as heavy plates, surface-treated plates and plate components. Due to the very low carbon equivalent, TMCP steels are easily weldable using all common processes. In addition, they are easy to form, bend and edge. TMCP steels give many monetary advantages to the shipbuilder. Reduced plate thickness. Saving weight in the final structure. Greater effective loads during use. Cost savings in welding and fabrication. Marine propulsion has seen great strides and innovations over the years. One of these was the creation of the mechanized marine propeller that truly changed the way ships could move, the distances they could travel, and the incredible speeds they could reach. Propellers work by pushing water away from the boat as they spin. This creates thrust, allowing the ship to move forward at a consistent pace. Exterior establishing shot of EMS Precab cabin factory. With the desire to build larger and larger ships came the need to accelerate the production process. Ensuring ships weren't sitting in shipyards year after year, while retaining the ability to push the boundaries, in terms of size. A key time-saving idea put into use in modern shipbuilding is creating prefabricated private and public areas that could slot in to the overall structure of the ship, which itself would likely also come together from multiple prefabricated sections. Ensuring that cabins are a balance of comfort and style is a key aim for a designer. Completed cabin unit being put on crane platform in building hall. cruise ship Braemar entered the Blohm plus Voss repair dock in Hamburg for a significant lengthening. Braemar, owned by Fred Olsen Cruises, will be extended by 31.2 m. Insertion of the new 2,250-ton midship section, fabricated by Shisho Seebeck Werft in Bremerhaven, will in this case, increase passenger capacity from 900 to 950, and crew accommodation from 300 to 360. The extra public space will include a second swimming pool with a children's play area and a bar designed like a British pub. In contrast to the construction process, the yacht will be cut into two parts and new blocks will be inserted. Blohm plus Voss will install approximately 150 kilometers of new cables in completing this project. Around 300 people, including both yard staff and subcontractors, will be involved in carrying out this work. In addition to the new midship section, a total of 18 new balconies will be installed on Braemar, and the restaurant on Deck 8 will be completely renovated. Various other public areas will also be either rebuilt or extensively refurbished during the projected 2-month stay at Blohm plus Voss.